Hello everyone, welcome back to TechOps tutorial. If you have been working with Kubernetes, you have probably heard terms like GitOps, Argo CD, continuous sync, and configuration drift. These topics are becoming very important in modern DevOps, but many people are not sure how they all fit together. In today's video, we will start with the basic. We will understand what GitOps is, why it was introduced, and the problem it solves. We will also learn the 4 core principles of GitOps, compare the traditional push-based deployment model with the pull-based GitOps approach, and see how Git becomes the single source of truth. After that, we will look at the complete GitOps workflow, explore some popular GitOps tools, understand why we are using Argo CD in this series, and finish with a high-level overview of how Argo CD works. Don't worry if some of these terms are new to you. By the end of this video, you will have a clear picture of overall GitOps workflow, and that will make the upcoming hands-on video much easier to follow. So let's get started by first understanding the problem with traditional Kubernetes deployment. Before GitOps becomes popular, most Kubernetes deployments follow a simple workflow like the one shown here. A developer writes the application code and pushes it to a Git repository. A CI/CD pipeline such as Jenkins or GitHub Action build and test the application. At the end of the pipeline, it runs a command like kubectl apply to deploy the changes to a Kubernetes cluster. This approach works and many organizations still use it today, but as the application and the team grows, some common problems start to appear. The first problem is cluster credential inside the CI/CD pipeline. Since the pipeline needs a permission to deploy to a Kubernetes, it usually stores cluster credential. If the CI system is compromised, those credentials could also be exposed. The second problem is manual changes. Someone might log into a cluster and run a command like kubectl edit or kubectl scale. The application continues to work, but those changes are not recorded in Git. This leads to the third problem called configuration drift. The configuration stored in Git no longer matches what is actually running in the Kubernetes cluster. Another challenge is difficult rollback. If a deployment causes problem, team often need to find an older version and deploy it again, which can take extra time and efforts. We also have limited visibility. It is not always easy to know whether the cluster is running exactly what is stored in Git without manual checking. Finally, there is a poor auditability. When changes happens in different places, it becomes difficult to answer simple questions like who made the changes, when it happened, and why it was made. So the main issue with the traditional approach is that the CI/CD pipeline pushes the changes to a cluster, but the cluster itself does not continuously check whether it matches the configuration stored in Git. This is exactly the problem that GitOps is designed to solve. Now that we have seen the problem with the traditional deployment approach, let's understand what GitOps actually is. GitOps is a way of managing both your infrastructure and your application deployment by using Git as a single source of truth. This means Git always stores the configuration that you want your Kubernetes cluster to run. Instead of making changes directly in the cluster, you make changes in Git and GitOps automatically applies them to Kubernetes. There are 4 important ideas behind GitOps. The first is desired configuration. This is the configuration you want your cluster to have. It includes things like deployment, services, replica count, container images, and other Kubernetes resources. These are written as YAML files and stored in Git. The second is the Git repository. The Git repository becomes a central place where all configuration is stored. Every change is recorded, so you can easily see what changed, who changed it, and even return to an earlier version if needed. The third is automated deployment. Instead of someone manually running kubectl apply, a GitOps tool automatically reads the latest configuration from Git and applies it to a Kubernetes cluster. The fourth is continuous sync. The GitOps tool keeps checking the cluster to make sure it matches the configuration stored in Git. If it finds any difference, it can update the cluster so everything is back to a desired state. A simple way to understand GitOps is through these real-world examples. Think of a blueprint for a building. The blueprint defines exactly how the building should look. If someone changes the building without updating the blueprint, the construction team will eventually restore it to match the blueprint. Or think of a recipe book. Every chef follows the same recipe, so the dish is prepared the same way every time. If the recipe changes, everyone follows the updated version. Another example is GPS navigation. You enter your destination once and GPS keeps checking your current location. If you take a wrong turn, it automatically guides you back to a planned route. GitOps works in a very similar way. Git stores the desired configuration, and GitOps tool continuously makes sure your Kubernetes cluster follows that configurations. Now let's look at 4 core principles of GitOps. These principles are followed by almost every GitOps tools, including Argo CD and Flux CD. Once you understand these 4 ideas, the rest of GitOps becomes much easier to understand. The first principle is declarative configuration. Instead of writing a command that tells Kubernetes what to do step by step, you describe the final state that you want. For example, you define how many replicas your application should have, which container images to use, and other settings in YAML files. The second principle is version control. All of these configuration files are stored in Git. Every change is saved as a commit. So you always have a complete history. You can see who made a change, when it was made, and if needed, return to an earlier version. The third principle is automatically applied. When you update the configuration in Git, a GitOps tool automatically applies those changes to a Kubernetes cluster. There is no need to manually run kubectl apply every time you make any changes. The fourth principle is continuously synced. The GitOps tools keeps checking whether the Kubernetes cluster matches the configuration stored in Git. If someone changes the cluster manually or something becomes different, the tool detects the difference and updates the cluster to match Git again. These 4 principles work together. You define the desired configuration, store it in Git, let the GitOps tool apply the changes automatically, and continuously keep cluster synchronized with Git. These are the building blocks of every GitOps workflow. Now let's compare the traditional deployment model with a GitOps approach. On the left side, we have push-based CI/CD model. In this approach, a developer pushes code to a Git. The CI/CD pipeline builds and tests the application and then runs commands like kubectl apply to deploy the changes to a Kubernetes cluster. On the right side, we have a pull-based GitOps model. The developer still commits changes to Git, but instead of CI/CD pipeline deploying them, Argo CD watches the Git repository. When it detects a change, it pulls the latest configuration and applies it to a Kubernetes cluster. The key difference is who performs the deployment. In traditional approach, the CI/CD pipeline deploys the application. In GitOps, Argo CD performs the deployment by pulling the latest configuration from Git. Now let's compare both approaches. First, cluster credential. In the push model, the CI/CD pipeline needs access to a Kubernetes cluster, so cluster credentials are usually stored in CI system. In pull model, the credential remains inside the Kubernetes cluster because Argo CD is already running there. Next, let's talk about rollbacks. In the push model, rolling back often means running the deployment pipeline again with an older version. In GitOps, you simply restore the previous configuration in Git and Argo CD automatically synchronizes the cluster to match that version. Another important difference is configuration drift. In the push model, someone can make a manual changes directly in the cluster, causing the cluster to become different from the configuration stored in Git. In pull model, Argo CD continuously compares the cluster with Git and updates it if it finds any differences. Finally, deployment history. With GitOps, every configuration changes is stored as Git commit. This gives you a complete history of your deployment and make it easy to see what changes over a time. This pull-based approach is one of the biggest reasons GitOps provides better security, consistency, and visibility than the traditional deployment model. Now that we understand how GitOps works, let's look at practical benefits it brings to your daily work. The first benefit is version control. Every configuration change is stored in Git as a commit. This means you always know what changed, who made the change, and when it happened. The second benefit is full history. Since all configuration is stored in Git, you have a complete record of your deployment changes. If you need to understand how an application was configured last week or last month, you can simply check the Git history. The third benefit is easy rollback. If a deployment causes a problem, you don't need to manually change the cluster. You restore the previous version in Git and the GitOps tool updates the cluster to match that version. The fourth benefit is automatic drift correction. Sometimes someone may accidentally change the running cluster by using commands like kubectl edit or kubectl scale. GitOps detects these differences and restores the cluster so it matches the configuration stored in Git. The fifth benefit is better security. Since Argo CD runs inside the Kubernetes cluster, the CI/CD pipeline does not need a direct access to a cluster. This reduces the need to store the cluster credential outside the cluster. The sixth benefit is fast disaster recovery. If a cluster is lost or need to be rebuilt, the desired configuration is already stored safely in Git. After connecting Argo CD to a Git repository, it can restore the application to their expected state. The seventh benefit is consistent deployment. Whether you are deploying to a development, staging, or production, every environment uses the same configuration stored in Git. This helps to reduce the mistake and keep deployment consistent. Finally, team collaboration. Developers, DevOps engineer, and system administrator all work with the same Git repository. Changes can be reviewed through pull request before they are applied, making collaboration easier and safer. These benefits are the reason many organizations use GitOps to manage Kubernetes application in production. One of the biggest problems GitOps solves is something called configuration drift. Configuration drift happens when the actual state of Kubernetes cluster becomes different from the desired configuration stored in Git. Let's understand this with a simple example. On the left, we have our Git repository. The deployment YAML file says that this application should always run 3 replicas. Since Git stores the approved configuration, this is our desired state. Everything is working correctly at first. The Kubernetes cluster is also running 3 replicas, so both Git and the cluster are in sync. Now imagine an engineer logs into a cluster and runs this command kubectl scale deployment nginx -- replica equals to 8. The cluster immediately changes from 3 replicas to 8 replicas. However, the Git repository still says the application should have only 3 replicas. Now Git and the Kubernetes cluster no longer match. This difference is called configuration drift. Without GitOps, these manual changes could remain in the cluster for hours or even days without anyone noticing. With GitOps, things works differently. Argo CD continuously checks the running cluster against the configuration stored in Git. As soon as it detects the cluster is running 8 replicas, while Git says there should be only 3, it defines the difference. Argo CD then automatically updates the cluster so that it matches the configuration stored in Git again. After synchronization, the cluster returns to 3 replicas and Git and Kubernetes are back in sync. This continuous monitoring and automatic correction is one of the biggest advantages of GitOps. It helps ensures that your Kubernetes cluster always matches the approved configuration stored in Git. Now let's understand one of the most important ideas in GitOps. Git becomes the single source of truth, but what does that actually means? It simply means that the Git repository stores the configuration that your Kubernetes cluster is expected to run. Let's look at the workflow. On the left, we have a Git repository. The repository stores the Kubernetes configuration files such as deployments, services, config maps, and secrets. This is the desired configuration that the cluster should always follow. In the middle, we have Argo CD. Argo CD continuously watches the Git repository and compares the configuration stored in Git with what is currently running inside the Kubernetes cluster. You will also notice the 3-minute default poll cycle shown here. This is the default interval Argo CD uses to check the Git repository for changes. If needed, the intervals can be changed. Many teams also configure Git webhooks, which allow Argo CD to detect the changes much faster instead of waiting the next polling cycle. On the right, we have Kubernetes cluster. This is the current configuration which represents the actual running state of your application. The important part is the comparison. Argo CD continuously compares the desired configuration in Git with the current state of the cluster. If both are same, no action is needed. If someone updates the Git with a new configuration, Argo CD detects the changes and synchronizes the cluster. Similarly, if someone manually changes the cluster and it no longer matches the Git, Argo CD detects the difference and restores the cluster so it matches the configuration stored in Git again. This is why the Git is called the single source of truth. Instead of trusting the running cluster, we trust the configuration stored in Git. The Kubernetes cluster is simply expected to follow whatever is defined in Git. Now let's put everything we have learned together and look at the complete GitOps workflow. This is the overall process that happens every time you make a change. It starts with a developer. The developer updates either the application code or the Kubernetes configuration files. Next, the developer creates a Git commit and pushes the changes to a Git repository. At this point, the Git repository contains the latest desired configuration. Now Argo CD comes into a picture. Argo CD continuously watches the Git repository. When it detects a new commit, it knows that the Kubernetes cluster needs to be updated. Argo CD then reads the latest configuration from the Git and applies those changes to a Kubernetes cluster. Once the update is complete, the Kubernetes cluster matches the configuration stored in Git. Finally, the application is updated and running with the latest approved configuration. So the complete GitOps workflow is very simple. A developer makes a change. The change is committed to a Git. Argo CD detects the update. Argo CD synchronizes the Kubernetes cluster and the application is updated automatically. The important thing to remember is the idea shown on the right. Every deployment starts with a Git push. Nobody logs into a cluster to make changes directly. Git becomes the starting point of every deployment and the Kubernetes cluster always follows the configuration stored in Git. This simple workflow is the foundation of GitOps and everything we will learn in the upcoming videos build on this process. Now that we understand the GitOps workflow, let's look at some of the popular GitOps tools available today. All of these tools follow the same GitOps principle that we have discussed. The main difference is in their features, user experience, and the type of team they are designed for. The first tool is Argo CD. Argo CD is one of the most popular GitOps tools for Kubernetes. It provides a rich web interface and command line tool and make it easy to see the deployment status of your application. It is widely used by organizations running Kubernetes in production, which is one of the reasons we will use it throughout this series. The second tool is Flux CD. Flux CD is another GitOps tool for Kubernetes. It is lightweight and is often preferred by teams that like working mainly from the command line. It follows the same GitOps principle, but it has a different style of working compared to Argo CD. The third tool is Jenkins X. Unlike Argo CD and Flux CD, Jenkins X combines both CI/CD and GitOps into a single platform. It helps automate building, testing, and deploying the application for Kubernetes. So why are there multiple GitOps tools? The answer is simple. Different organizations have different requirements. Some teams prefer graphical web interface, others prefer command line tools. Some need only GitOps, while others want CI/CD and GitOps together in one platform. But regardless of which tool you choose, the core GitOps principle remains the same. You still store your configuration in Git, use version control, automatically apply the changes, and continuously keep the Kubernetes cluster synchronized with Git. In this series, we will focus on Argo CD because it's widely used, beginner friendly, and an excellent way to learn GitOps concept before exploring other tools. At this point, you might be wondering why we are using Argo CD for this series instead of another GitOps tool. There are several GitOps tools available, but Argo CD is an excellent choice for both learning and real-world Kubernetes deployment. Let's look at the reasons. The first reason is that Argo CD is a CNCF graduated project. This means it is reached a high level of maturity and is trusted by many organizations running Kubernetes in production. Second, it provides a rich web UI. Instead of relying only on command line tools, you can open the web interface to see your application, deployment status, synchronization state, and health information in one place. Third, it's easy to learn. The concepts are straightforward and the user interface make it easier to understand what is happening inside your Kubernetes cluster. The fourth reason is that it is production ready. Argo CD includes features that organizations commonly need when running an application in a production, such as high availability, role-based access control, and authentication support. Next, Argo CD is GitOps focused. It was designed specifically for GitOps on Kubernetes, so it provides the feature needed to manage Kubernetes deployment using Git. Another advantage is its large community. Since many people use Argo CD, you will find plenty of tutorials, documentation, examples, and community support whenever you need help. It also has excellent documentation. The officially documentation explains installation, configuration, and advanced features in a clear and organized way. Finally, Argo CD is widely used in production. Many organizations, from small teams to a large enterprise, use it to manage Kubernetes application. For all of these reasons, Argo CD is the tool we will use throughout this series. Once you understand GitOps with Argo CD, learning other GitOps tools like Flux CD becomes much easier because the core concept remains the same. Now let's take a high-level look at the main components of Argo CD. Don't worry about remembering every component right now. The goal of this slide is simple to understand the overall flow. We will explore each component in detail in a later video. Let's start from the left. The first component is the Git repository. This is where all of our Kubernetes configuration is stored. It contains your YAML files, Helm charts, and customized configuration. Since Git stores the approved configuration, it acts as a single source of truth. Next comes the repository server. Its job is to read the Git repository and prepare the Kubernetes manifest that will be deployed. If you are using Helm or Customize, this component processes those configurations before they are sent to a next stage. After that, the manifests are passed to that application controller. This is one of the main components of Argo CD. It continuously compares the configuration stored in Git with what is actually running in the Kubernetes cluster. If everything matches, it does nothing. If it detects a difference, it starts the synchronization process to update the cluster. Finally, we have a Kubernetes cluster. This is where your applications are actually running. Argo CD applies the approved configuration here and then checks whether the cluster matches the desired state stored in Git. You will also notice 3 supporting components at the bottom. The API server provides access for the Argo CD web interface and command line tools. Redis stores temporary data to help Argo CD work more efficiently. And DX handles user authentication, making it possible to integrate Argo CD with identity providers such as LDAP or single sign-on system. For now, don't worry about the internal details of these components. The important thing to remember is this simple flow: GitOps repository, repository server, application controller, and then Kubernetes cluster. This is the basic architecture behind how Argo CD continuously keep your Kubernetes cluster synchronized with Git. Now let's connect everything we have learned into one complete GitOps workflow. By now you have already seen each of these steps individually. This slide simply brings them together into one complete GitOps workflow. It starts with a developer who updates the application code or the Kubernetes configuration files. The developer then creates a Git commit and pushes the changes to a Git repository. Argo CD detects the new commit and compares the desired configuration stored in Git with the current state of Kubernetes cluster. If both are already the same, no action is needed. If there is a difference, Argo CD synchronizes the Kubernetes cluster so that it matches the configuration stored in Git. Once configuration is complete, the application is running with the latest approved configuration. This entire process repeats every time a new change is committed to a Git. The most important message from this workflow is shown at the bottom. Git becomes the single source of truth. Developer makes changes in Git, not directly in the Kubernetes cluster. Argo CD continuously compares the cluster with Git and automatically synchronizes it whenever changes are detected. This simple but powerful workflow is the foundation of GitOps and is the reason deployment becomes more consistent, reliable, and easier to manage. Let's quickly recap what we have learned in the first episode. We started by understanding why GitOps is needed and the problems with traditional Kubernetes deployment. Then we learned the 4 core principles of GitOps and compared the traditional push-based deployment model with the pull-based GitOps approach. After that, we understood configuration drift, why it happens, and how Argo CD automatically detects and corrects it. We also learned why Git becomes the single source of truth, walked through the complete GitOps workflow, explored some popular GitOps tools, understand why we are using Argo CD in this series, and finally looked at its high-level architecture. The most important things to remember from today's video is this: every deployment starts with Git commit. Argo CD detects the changes, synchronizes the Kubernetes cluster, and keeps it aligned with the configuration stored in Git. In the next episode, we will start building the foundation for our hands-on GitOps journey by learning how to structure a Git repository for GitOps, including how to organize the repository, folders, and environments. If you found this video helpful, please like the video, share your questions in the comments, and subscribe to TechOps tutorial so you don't miss the upcoming episode. Thanks for watching, and I will see you in the next episode.